thing. Okay, cool. That only took 5 minutes out of my time. Awesome. All right, I'm going to try to get this back on track here a little bit. Thanks for being patient with technical stuff as we're trying to work out how to do this in person and in hybrid. Anthony Robinson, I'm from Penn State. Let's try this again. I'm a director of Geospatial Education Programs at Penn State University, and I co-direct the new Geographics laboratory at the Gould Center. And I'm going to talk about viral cartography and social media and what I mean by that today. Let's see if we can get this going here. There are lots of different objects in social media that get shared widely, and there are maps in this mix at the moment. And there's not really a single way to define something like virality, but one of the ways to keep it in mind that's been theorized is that if lots of individuals share something, that's more important, that's more viral than one person with a large audience sharing something to their large audience. So an example that I get all the time is like when my parents or my sister or someone who doesn't do my work sends me a map she thinks is interesting. That sort of raises the level of virality, right? That's a way to think about it. Viral maps can be original works. They can be modifications of originals. I'm going to show you some examples today. They can be reposts of older maps. One of the best examples of that is Andrew Woodruff's daylight savings maps, which every year in the United States, when daylight savings kicks in again, his maps go viral again. So they come up actually twice a year in the United States. It's probably a brilliant example of that. And one thing I'll propose today is that a use case for machine learning is to look at the sources and modifications and spread of viral maps, maybe kind of a place where these things intersect. One of the examples that really inspired me to get into this was the run up to the 2016 US election disaster. This particular map here was made by a guy named Nate Silver, who runs like a stats visualization sort of blog kind of thing, if you want to call him that. And this particular map is a hypothetical. It's what would the election map of the United States look like if only women voted? This was in the wake of an Access Hollywood tape by a guy who's orange. And it was a really bad moment in US politics amongst many others. But this particular map got lots and lots of retweet action. A lot of other people were inspired by it. It made them think about the election landscape in kind of a different light. This is a hypothetical situation. It's not one that could really happen, but it makes you think about it a lot. One of the interesting things I saw with this was the number of maps that were made in response to that original one. So what if only X voted? There was all kinds of variations, hundreds and hundreds of variations that people made on their own in response to that original kind of viral map seed. So I got really curious about how to try to understand, you know, what are all the other different variations here and how did those emerge as a result of this initial viral map? So it got this kind of original kind of seed here, and this viral sort of infects and makes lots of other things. I started working on this right before the pandemic began, and I didn't realize that like viral maps would then become like literal and kind of a pretty bad thing. So sorry about that. A way to begin attacking this, I had this collection. In this case, I had collected 500 maps from Twitter that were what if only kind of X voted. A way to look at that, one way to look at it, is collect those kinds of maps, extract the image URLs, and run them through a service like Google Cloud Vision. So this is a black box algorithm that attempts to show something about the structure and characteristics of those images, where they might be found on the internet. And so I did some work with this. You can read a lot more about the methods here. I have a 2019 paper in Cages about it. I won't go into detail since we're already way low on time, especially with my Zoom expertise. One of the things we get, though, if we look at these kinds of election maps, an algorithm, machine learning black box algorithm like Google Cloud Vision gives you something called image labels. So this is kind of the structure of an image as read by a computer. It's kind of a computer vision thing here. Good news for cartographers is that the most relevant image label for a set of 500 of these what if only X voted maps that were curated by me, I'm a cartographer, came up as map. So the algorithm kind of agrees that these are mappy. Came up with words like area, font, world, ecoregion. There are other similar kinds of image labels in that mix. There's also some interesting ones like organ, let's see, product design, who knows what the hell that's about, diagram, illustration. So there are some sort of related, the organ one is kind of interesting, I think, because of, if you think about the shape of the United States being kind of like bacterial, that's my guess, is that it's like a weird, like the coastline of any place would be really erratic and look a bit like bacteria. Now, if you look at something else that you can get from machine learning algorithms like this, that would be the related things on the internet. So Google Cloud Vision calls these web entities. So this is actually sort of more of the content of the image and how it relates to how people are talking about it. So from the same set of images, now we have United States comes out, which is right, that's relevant. Map, Donald Trump, Electoral College, Hillary Clinton. So we start to see the things that the maps are actually about. So between the two different types, you have image labels and web entities. You can start to construct, if you have thousands and thousands of maps, something about how they're designed and also how they are related to discourse, how people talk about them. So that's one side of the puzzle here. Another side that I want to talk about is what do you do when you don't know where a map came from, and how do you start to understand where modified maps come in? So Arzu mentioned misinformation as a potential area of cybercartography earlier, and I'm going to come at it from a slightly different angle here. One aspect that's tricky about this is we might have someone tweet something and we know that that person made this map because that's what they do. Like this is a web, basically an article by somebody who creates new things. A related example that happened in the same kind of 2016 frame here was this compilation on the other side there, which was tweeted by lots of different people, but it was very unclear actually who made the original compilation. Its actual original source was not really easily known. So I used some reverse image search tools. There's one that's really nice and kind of fun to use called TinEye. It's another black box algorithm corporate kind of platform for reverse image search. What you can do with platforms like that use machine learning is take a seed image and say, find me all the things that are close to this. And it's a reverse image search. So you can find complete and partial matches for images on the web. So there's 5 examples here of partial matches to that original one, including one where someone else had the same question I had, which was, does anybody know where this image came from? And then the others, there were several others that have been translated into other languages. So it's really interesting. You can actually find like other people that took a viral image and then began to subtly modify it and change it for a local audience potentially. We don't know whether or not those are correct translations though, right? So there's a lot that could be changed. If I just change the legend on a map, I change completely its meaning, right? A more recent example here that's kind of a fun one. Many of you might have seen this in the last couple of weeks about like, will you receive food as a guest at someone's house? There was this whole viral thing about Sweden, which apparently if you go, like if you spend the night at a friend's house in Sweden, they're not going to feed you, which is kind of weird. I mean, sorry, if you're from Sweden, it just seems strange. And I like how that's different across Europe, right? So there's this Instagram account by this lover of geography, whatever the hell that is, right? Who put this thing out. This is not really, I mean, how do you know, right? The veracity of this map is low. But what's really fascinating to me is how this spread around. It became something shared very, very widely. One of the most common reverse image search results of this is actually stripping out the where it came from parts. So if you look, this is the most common, like sort of next most relevant result here. Just takes out this little, I don't even know what that is, and then takes out this lover geography source information. If you go to this person's Instagram now, they watermark the hell out of all their maps to make it harder to do this in the future. And then my favorite modification was this one. This is someone who took this original one and said, and basically just changed the title, right? Will the detective investigating your murder be sad? And it just talks, it's sort of riffing on stereotypes about Scandinavia, right? And TV shows about detectives in the North, right? I guess this is something we have all around the world now. So a cool example about using reverse image search to kind of explore a little bit. One of the other examples that comes up a lot with this with TinEye is just the original grayscale Shutterstock image that this person almost certainly used to make their original graphic. It's just like a stock map of Europe here, parts of Europe here, that's just grayscale SVG that someone can use. So it probably came from that stock image source. All right, so how would we do if we put all this together? I got 2 whole minutes left on my clock here. We have a tool at Penn State we built called MapReverse, built by Shi Zhu, who's he's a postdoc. He was a postdoc at GeoVista, Penn State. Now he works at Apple. And what we did in MapReverse is put these things together a little bit. So we started to build a little tool that lets us look at similar maps to original viral maps. So we can use TinEye, process an image, find all the like the 50 most similar images to an initial seed. We can look at the metadata for each of those similar images. So tell me more about what the sources of those things, how big are they, where do they live in the internet. We can filter potentially by when those things were posted, and their TinEye provides like a a number that it kind of uses to index similarity of one image to the next. You can't really decompose it and know much about what exactly that means, but it is an index. And then there's also entities and domains. This comes from Google Cloud Vision. So like, what are the topics on the internet that relate to those images? So we put all those things together in MapReverse. And one very quick example of this, during the 2020 election cycle, famous cartographer Lara Trump posted this about try to impeach this. This is trying to make the case that there's a lot of areas with very low people that vote Republican, so that means that he should always win. We started to look at that image because when I saw this posted, I'm like, it's super artifacted, it's really bad looking. That was the original, and I'm like, something's weird here. Like, this has definitely been repurposed from an older image, right? So we started playing around with this in MapReverse. We found a bunch of previous examples, including this very uplifting behave or be extinct example. And then actually this got picked up in the media a little bit because the Trump campaign had actually photoshopped out some big blue counties to make it even more red, because it wasn't red enough, I guess, for the big orange cheesehead. So so this is a good example of a slight modification. This is absolutely just straight up misinformation, right? Or I'm just going to change the choropleth map with some results here. I'm going to make people think that this is the real result. And you can see that very subtle difference there. And it's just a few counties. That's like total erasure of the people that live in those places. It's not okay. So if you'd like to play around with a bunch of other examples, there is a tool up at mapreverse.org that should work for you right now. I won't do a live demo since we don't have time today. But mapreverse.org, you can play around with that. There's several different other ones, including the initial part of the coronavirus pandemic. There was this map of airline routes around the world that went viral because it was purporting to show where people could go from Wuhan or something. It was completely BS, but it's a good example of another one that spread around everywhere very quickly, and people began sort of reading into it. Also, Australian fires, which you've already forgotten about by now, late 2019. That was just a 3D rendering. It's not actually a thematic map based on data, but it also, people began to believe that like all of Australia was on fire because of this one viral image. The final thing I'll mention here is a couple of frontiers that I think are interesting. A lot of you have probably seen examples from DALL-E, which is this generative algorithm for making any kind of image using machine learning. For fun, I started playing around with this a little bit with some of these examples, like what happens if you just tell it election map? You get an American election map, sort of, kind of a beautiful one. Less, some blue and some red, but not only, kind of weird, strangely. But I did 2020 election map results because I thought maybe if I get more specific, it will like start to generate something a little bit more specific. I don't even know what the hell it's doing. This might be a county map that DALL-E is trying to process, right? It's very primitive. And then I said, all right, these are like very US. That's very close to that chair. What happens if I look at like the French election that just happened? So I looked that up in French and I got whatever that is, right? So it's very primitive at the moment, but you can imagine like generative maps that look plausible are also, that's definitely going to happen. And there are other folks who have made generative algorithms to make fantasy maps and other things like that that look quite plausible. There's some cool stuff with remote sensing imagery as well, where people have automatically generated plausible looking satellite images of places that don't exist. So this is coming. So we have to think about how we're going to deal with that. Also on the open source side, I wanted to mention this because if you're interested in doing this verse image search, it's very frustrating since most of the ways of doing this are black box algorithms that are owned by companies. But resemble.js, there's a great site on GitHub that you can start to roll your own kind of thing, leveraging JavaScript. And if you wanted to automate it with Python, you can. So in this example, I've compared infamous kind of Sharpie map where Donald Trump just made the hurricane go further versus the original weather service example. And you can highlight the differences with something like resemble.js. So kind of a fun thing to play with and a good starting point if you're interested in doing further research on this. I think there's quite a few different challenges here for us to work on next. I think understanding the differences between the reverse image search algorithms that exist, also some of the web entities and content related ones. I think we need to make it clearer for users when something has been derived. So knowing that it's a modified map versus an original, I think that if I was a user, it would be helpful to know that this has been changed in some way. It's going to be very tricky to do that. I think there's also a lot of potential here to use some of these methods to immediately detect new viral maps. So a map design that doesn't come up in a reverse image search, right? So we haven't seen this particular thematic map before. That's useful to a user as well. Like this is a novel thing. Or, gosh, this has been out there for years. Like you're just seeing an old thing that's been reposted a million times. And I think there's an entire streak of work, of course, trying to understand more about how people that read these different graphics actually interpret them, what they do with them afterward, how does that impact their trust in mapping in general. And with that, I will stop. If you're interested in this kind of topic, you're welcome to join the ICA Visual Analytics Commission. Arzu and I actually co-chaired that commission. And the slides are also available here at tinyurl.com/agile22 if you'd like to get those. So thank you. I tried to make up a little bit of time here, but thanks.
Thank you very much, Anthony, for this wonderful presentation. Very exciting. Maps are back in all forms we can think of. We have all these new cartographers preparing things for us. Questions?
Can I ask one?
Yes, yes, please.
I would like to ask Anthony if he was able to create a viral map himself.
Yeah, that's a good question. Thanks, Arzu. I haven't done this yet, but I'm very tempted to try to make a viral map and make it happen on purpose and to be able to witness kind of what happens from that. I asked my undergraduate students in class recently about I showed them this kind of example as part of a little modular research, like what do you think would make a viral map? And I had some good suggestions. My favorite one was to make a map. There was a student who suggested making a map about the best fishing lure to use in each state of the United States and make them wrong because it will make people mad. And that's an element of virality, right? Sometimes when you see a map, for example, the whole thing about like Sweden, that will you get food if you go to a Swedish person's house? Like a whole bunch of people from Sweden were like, no, that's wrong. We would totally get someone food. So it's a little bit like if it challenges you against what you think is correct, that seems to have some relationship to whether or not something can go viral. If it causes people to argue, right? If it challenges your prior assumptions. So the fishing lure one was good because it's kind of harmless. I do think that you could make a viral map though that harms people a lot. So I think that's a danger in experimenting in that way, is that you would need to be sure that your example is not going to actually like cause conflict or strife or hurt somebody's feelings badly. So there's a really challenging element there, I think, in coming up with an example that would work, that would prompt people, that would provoke people, but also not necessarily like cause harm. There's an example in Mapperverse that shows, this is a viral map from a long time ago, back when people would email things and forward to each other, purporting to show fallout from Fukushima. And it's completely made up. It was an utterly false, not correct thing. It circulated very widely in 2011. And I still haven't been able to figure out, because reverse image search stuff doesn't go back that far, like who made that? Where did that come from? Because it's straight up disinformation, and it's disruptive to people actually trying to solve problems that are real, that impact people's lives. So you can imagine somebody doing something viral that actually really harms people in a evacuation in an emergency kind of scenario, like go this way, not that way. That's pretty scary, right? And people could do that faster than officials would ever be able to make real guidance that fights it. So I think that's a great question, Arzu. Thanks.
Good. Anyone else, even from Zoom? Any other question?
Yes, I have one.
Yes, Eleni.
Thank you. I have a question about the variety of maps. Do you have any idea on the bigger context of virality of things on internet? What is the ranking of maps being viral?
Yeah.
I mean, because there are many other things that are more viral than maps, and I would like to know if maps are really viral on internet in a sense that to know for us map practitioners if our products have an appeal on people, like they have TikTok videos or other images of celebrities. I don't know. Is there an information on how viral actually maps are?
So it's a really good question. The question is like, do we know how viral any given map, even like the Nate Silver example, is versus all other viral media?
Yeah.
And how would you begin to know that? To my knowledge, there isn't a simple answer to solving that problem. And a frustrating thing about the folks that have proposed concepts of structural virality, there's an algorithm potentially for sort of measuring is something structurally viral. You still have to decide what a threshold is for virality as the user of such an algorithm. There's very few implementations of that. So in actually measuring virality in some way, I think we have to measure virality. If come up with a way to agree that we're going to measure virality, I think measuring the structure and looking for lots of small nodes sharing versus one big broadcaster is a way of doing that. And I can point you to a link of some folks who have worked on that, but there are very few. I was trying to understand the same kind of thing, like how meaningful are these in discourse? Are they very popular for real or just popular amongst them?
Appealing.
Yes.
That's my original question, actually.
Yes.
What I would like to know.
And I think that's crucial, understanding why people get really interested in some of these maps, what intrigues them in cases like trying to communicate hazards from climate change and mitigation for COVID-19 and things that are real, that are big problems that face humanity and need the additional juice that virality could give them, instead of just like silly stuff like, are you going to get food when you go to from a friend's house in Sweden? Like everybody's like, oh, that's fun. Is there anything we can translate from that to make people pay attention or really dig into the more meaningful stuff? So I totally agree with you, and I think there's a lot more work that has to be done.
Thank you.
Yes. I don't know. Yeah, you go first.
It's a short one. Did you identify a social media on which maps are most viral?
So yeah, I haven't done a comparison of channels. I think that's also an interesting thing. Most of the work that we've done so far is focused on Twitter. I think there's a lot yet to be done with, I would like to look next at Reddit. And in particular, some of the map subreddits would be really interesting because those are curated, or those are individuals who are working to sort of elevate interesting content. And it's not necessarily just dependent on serendipity, which is what I would guess is more what's happening with a lot of things on Twitter. There are other sources, for example, I think image hosting would be an interesting place to look. So Imager, for example, when you think about Reddit, you also think about Imager. A lot of the things that we found when we were trying to look at metadata for reverse image search are just all of these image hosting sites. So that's a really big problem, actually, because those tend to be ephemeral. They tend to go away. And so you'll have a tweet with like an embedded image from a few years ago. That image URL is no longer, doesn't exist anymore. Like image hosts kind of tend to come and go. They don't keep stable URLs. There's a big archiving issue with trying to study that problem, I see. That's definitely an open area though. And then platforms like TikTok and others, you can't get access to at all, so we don't know. It'd be great to see WhatsApp stuff, for example. Are there map images on there? I'm sure there are, but there's no way at all for us as researchers to see into that. So we're kind of limited at the moment.
One probably last one.
Yeah. I guess we're going to talk after coffee.
My question is related to hers. You said that there's no simple way to like measure or define virality. But in your case, what kind of threshold or pattern, like resharing pattern, did you use to say this is viral?
So in the work I published in 2019, I didn't try to calculate structural virality. I looked at a couple examples where I'm picking, because I'm like in the Nate Silver example, there's tens of thousands of people that retweeted this thing. It clearly has a big audience, and there were hundreds of maps to result. There is a paper by Goal et al. That is in that 2019 article I can point you to, where they propose this measure of structural virality. And in theory, you could calculate a number that tells you, at least comparing examples, like this one has more structural virality than this other one. But like I mentioned earlier in the previous question, there are frustratingly few implementations of this algorithm. And the things that we see as trending on sources like TikTok or Twitter. Otherwise, we don't actually have any access to how they are calculating that. So there is a science theory about virality, and then there's the implementation that we actually experience. And those two things, to the best of my knowledge, are actually not connected. So it's a really tricky, because that's like one of the thing that started me off in this was like, can we just detect viral maps right now and show them? Like today, what's a viral map? Show me the most viral map today. Seems like a pretty straightforward question, right? Like, no, because you have to establish some kind of measure of what does it mean. That measure in theory exists, but we can't compute on the whole set to know it yet. So I think that's definitely an open research challenge to try to figure out how to get ahead of that. And maybe something to do with image hosting would help with this. So you might be able to access image host APIs to look at what's being kind of reshared quickly and then compute off of that.
Good. So if you're not next to ask another question, we should stop here, break here.